and this unit we'll be talking about area. Now, to find the area of a triangle, what you guys have learned is this. The area of a triangle, you do 1/2 base times height. That's what you guys learned for everything. So if I look at this triangle right here, let's apply that. What we're going to do is draw in the height right there. So let's call that H. And then the base we can see here is A. So currently in my formula, I have 1/2. I do have the base, right? I can just write in A. And I also have the height, which is H. But we want to use some trigonometry to make a nicer formula. So imagine you're standing right here. Let's do some trig on the side. Sine of C should equal, and notice how if this is B over here, this should be little b. This should be H over B, which means H should equal B sine C. So let's plug that in right there. And now I have a pretty cool formula. A is equal to 1/2 AB sine C. And that's going to be the first formula we're going to use today. So again, on our notes, let's write area formula. A equals 1/2 AB sine C. And just like the law of cosines, the letters are arbitrary. I mean, we can reassign them as long as they fit the pattern. So I can do 1/2 BC sine A, or I could do 1/2 AC sine B. And all of those are going to work. Okay, and the main thing to know for this triangle, so let's box that, or for this formula I should say, the main thing to understand is this is only for side angle side triangles. So it's a great formula, and it works really well with side angle side triangles. And this formula does come up in the ACT as well. Not really the SAT though. Let's go to the first one. Find the area of a triangle for which A is 8, B is 6, C is 30. So just draw a triangle right here. Fill it in. ABC. A is 8, B is 6, C is 30. First verify that we are in the side angle side case, and we can see that side angle side. So our formula is going to be 1/2 the two legs, 6 times 8, and then sine of the included angle, 30. Now you could use a calculator, but there's no need to, because we know what 1/2 of 6 is. That's 3. 3 times 8 is 24. And then sine 30 is 1/2. So the area is just 12, and I'll write u squared for units. And there's our first problem done. Now the last formula we're going to talk about is going to be called Heron's formula, because notice in this problem it's saying a side, side, side triangle. So if I were to draw this, it says this is 4, this is 5, and that's 7. And that's really all we know. And it said, let's figure out the area of that. So if I asked you, could I do the formula we just learned on this one? We would say no, because there's no angle given. So for this one, we have another formula. This is called Heron's formula. This one I'm not going to prove. The proof is actually pretty crazy, so we're not really going to go over that in this class. If you're more interested in it, we can talk about it on the side. But this proof is pretty crazy to show. It's not quite as simple as the others that we've done. And it looks really hard, but applying it's actually not that bad. The only thing you have to know is that this S stands for semi-perimeter. What that would mean is 1/2 the perimeter. So essentially you use this formula if you ever want to find the area of any triangle where you have all 3 legs. So let's try it. I'll rewrite it here. Area is equal to the square root of S, and then you just use S and subtract it from everything. So the first step is obviously we want to find S. So let's add up all the sides. 4 plus 5 plus 7 divided by 2. So that would be 9 plus 7 is 16 over 2, which is 8. So there's our S. And then the best way to show you work for this is going to be plug in S, 8. And then do this part in your head. Just use 8 and subtract it from each leg. So 8 minus 4 is 4. 8 minus 5 is 3. 8 minus 7 is 1. That way you kind of save yourself some writing. And now we work it out. A is equal to the root of 8 times 4 times 3. Now again, we could use a calculator, but let's say we didn't have a calculator. Let's just do some manipulation here. So 8 is 2 times 4, and then that's 4 times 3. Notice how there's two 4's right here. So let's just pull those out. 4 root 6 units squared is our answer. Now the one thing to know about this formula, what's interesting about it is notice there's a root. So it is possible that if you were to try this formula, and let's say we were to try it with these legs, 2, 3, and 5. Let's actually try it. So S is going to be 2 plus 3 plus 5 over 2. So S would equal 5. That's just 10 over 2. If we were to actually try this, area equals square root, that's 5. 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 5 is 0. Notice how you get 0 here. Why does that happen? Well, again, that's because if you look at these legs here, these legs are impossible. You can't have a triangle with legs 2, 3, and 5. That's what we talked about last class in the triangle inequality. So the formula is also useful because this part right here, it will tell you if the triangle will even exist. So it'll confirm triangle's existence. Meaning if it became 0, the triangle is really not possible. And if it became negative, you know that as well the triangle would not be possible. Right, that's our lesson on area. That's it.